Alright, so this is going to be the first of a few guided sessions for your participation and what you need to do in this co-rec course. Okay, so before we get started, a few things that you need to know. There is a link that is in Blackboard. I'm sure you've seen it. It's right near where the lecture recordings file is. That says course participation or class participation submissions. So essentially, we are going back to the way we started the course in the beginning of the semester, which is working through the supplemental textbook. Now, if you remember, that textbook had been uploaded to Blackboard from the beginning. So now what's going to happen is we're going to do a mini lesson where I'm going to cover some basically the extra examples, kind of touching base on those examples again. And then what you have to do is you have to complete the practice problems that are in that book, and then you need to upload whatever you did into the submission, and that's how you're going to get participation for that section. Okay, so whether you're taking pictures or you scan and submit a PDF, I mean, however it is you choose to do it, you just have to show me that you are working through that book in order to get the participation for those sections. Okay. So this one is going to be the one covering 3.3, which in the lecture class we learned was other common functions. Okay. So what we're going to do is we are going to look at some examples here. So first and foremost, let's start here where it says f of x is negative x squared over 2. Well, here we can rewrite that as negative 1/2 x squared. And in doing so, thus now we can see what that base is. So the base function here is going to be x squared. Once we identify that, we can then create that xy table. So here we're going to create x, and then we have that f of x equals negative 1/2 x squared. Okay. So first and foremost, we can look at 0. So plug a 0 in, negative 1/2 times 0 squared. So 0 squared is 0 times 1/2, or negative 1/2, still gives you a 0. Now, because this is a fraction, I'm going to make things easy. So I'm going to hope that I can work with some combination number that's going to give me something easily cancelable with the 2. So the first thing I'm going to look at is I'm going to look at positive 2. So here I've got negative 1/2 times 2 squared. Well, 2 squared is 4 times negative 1/2 is going to give me a negative 2 as a result. And then I'm going to go ahead and use negative 2 because I know it should come out to be the exact same thing. So negative 1/2 times a negative 2 squared is going to give me negative 2. So I need to graph those points. Okay, so I'm going to go ahead and do that. So the first point that I have is I have the point 0, 0. So I'm going to go ahead and graph that in. And then I have the points 2, negative 2. So 1, 2, 1, 2. And I have the point negative 2, negative 2. So 1, 2, 1, 2. And I'm going to go ahead and draw my graph in. Okay, now it doesn't have to be perfect, but it does need to be close. And since I have a negative out in front, that should make sense then that my graph should point down. So now let's look at another one. So we have 1/3, or x cubed plus 3. So first and foremost, we know that base function here is going to be x cubed. So this is the first time we're working with an x cubed. And so again, I'm going to create my x and then my f of x table. And I'm going to start filling it in, okay? So the first thing that I would do is, again, I would choose my 0. So here, this is going to give me 0 cubed plus 3 gives me 3 as a result. So now, I have to kind of figure out what's going on with my function. And so I'm going to go 1 on either side, positive and negative. So I'm going to pick a 1. When you do that, you get 1 cubed plus 3 is going to give you 4 as a result. And now I want to look at negative 1. So my negative 1 cubed plus 3. Well, when you cube your negative 1, it stays negative. So this is negative 1 plus 3, which gives you 2 as a result. So if we take a look at just those 3 points to start, now I'm not saying we're done, but looking at those 3 points to start, the first one we have is 0, 3. So 0, 1, 2, 3 is right here. And then we went 1 and up 4, so that's this point here. And then we went negative 1, but in that case we only went up 2. So if you look at it, it does appear to be linear, but it's cubic, so it's going to be curved a little bit. But now we need to know what's going on with our curve. So I'm going to go 1 more on either side, and I'm going to look at 2 and negative 2. So here's 2 cubed plus 3. 2 cubed gives you 8 plus 3, which is 11. Well, clearly if I do that, it's going to go straight off the graph. So here, this one is kind of curving, but then here it shoots up really fast. If I look at the other one, I'm going to have negative 2 cubed plus 3. Well, this is negative 8 plus 3, which gives me a negative 5. So 1, 2, and then 1, 2, 3, 4, 5. So that point's right here. So this is then going to come down, and it shoots down really fast, goes through 5, and keeps going. Okay. So that right there is your graph. So as you can see, it travels up, goes through my points, and continues to travel up. And it has that twisted paperclip look, so you know that you graphed it correctly. Now let's look at the absolute value of x minus 6. So here, my base is going to be the absolute value of x. So again, we've got x and my y value. So because I have this subtraction inside my absolute value, I need to be a little more smart or careful with the choosing of my points. So the first thing I'm going to do again is I'm going to look at 0. So this is going to be the absolute value of 0 minus 6. Well, 0 minus 6 is negative 6. Apply the absolute value, you get 6 as a result. Okay. Now, in looking at this, I want to choose a value that's going to give me 0, because remember, most of the time, you're going to have a point where you're sitting on your x-axis, or potentially. And so here, I'm going to look at, okay, what if I chose 6? Well, that's going to give me the absolute value of 6 minus 6. Well, 6 minus 6 is 0, and the absolute value of 0 is 0. So I have 2 points. I need a couple more. So in order to figure out what points I want to choose, I'm going to go ahead and graph these 2 points and see what they look like. So I have the point 0, 6, so 0, 1, 2, 3, 4, 5, 6, so that's going to fall right here. And then I have the point 6, oh sorry, 0, 6, 1, 2, 3, 4, 5, 6, and then I have the point 6, 0, which is going to fall right over here. Okay, so if you remember, absolute values look like a V. So I'm going to assume that this right here is that vertex point. So my assumption is that this is going to be where your vertex is. So I'm going to look at going to the left of it and going to the right of it and see what happens. So the left of it means I'm going to choose that x is 5. So when I do that, I have 5 minus 6. Well, 5 minus 6 is negative 1. When I take the absolute value, I get a positive 1. So this is going to be the point 5, 1, so it's going to sit right there. And now, to prove that this is my vertex point, I'm going to look at that point to the right. So that point to the right is a 7. So here I'm going to have the absolute value of 7 minus 6 is equal to the absolute value of 1, which is 1 as a result. So here's 7, I do go up to 1. So if you see, you can kind of start to see that V shape appearing, which is exactly what we wanted. So then, if we look at it closely, we've got this side of my graph, and then we've got the other. Now, your V here is obviously going to go straight off the page, which is fine, but then that is how you would graph it. Okay. Last, I wanted to look at a couple piecewise examples, just so that you have a little bit more under your belt. Again, excuse me, you need to remember that in order to evaluate, you have to determine which domain your evaluation falls in, and then use only that piece. Okay, so again here, if you look, I've got 3 separate functions, all boiled to one, and each of these functions has their own domain to which they follow. My top function is x plus 1, and it satisfies all values less than negative 2. My middle function here is 5, and it's going to satisfy all values between negative 2 and 3. And then my bottom one here is x squared, and it is going to satisfy all values for x greater than 3. So the first thing I have to do is I need to find f of negative 4. So I have to determine, that first step, which function am I using? Well, negative 4 is going to fit into my first domain because negative 4 is less than negative 2. Therefore, I'm looking at the function x plus 1. So to evaluate, f of negative 4 means negative 4 plus 1, which equals 3, negative 3 as a result. Now the other one is f of 0. So if you look at that first one, again, we're looking at all values less than negative 2. Well, 0 does not qualify. So then if we look at the middle one, my middle one is going to go values from negative 2 up to positive 3. Well, 0 is going to be housed in that if you think of your number line. So therefore, identifying the equation means we are looking at the function f of x equals 5. So to evaluate, f of 0 then is going to give you 5 because this is that special horizontal line. Okay, so there's nothing for us to do except for to state the result. Now again, graphing is where you need to look at all pieces individually and then create their graphs from there. Okay. So first and foremost, we have to look at what we have. We have 3 functions here. And in these 3 functions, there's a mini mistake that I need to correct. So this bound right here should not be equals to, it should just simply be less than. Okay, so we're going to correct that right now. So first and foremost, we have x, and then f of x equals 4. So we are looking again at the bounds, and this is going to be all values that are less than 0. So I need to start with that bound value. So my bound is at 0. And it's less than 0, so this means an open circle. So I'm going to put a small open circle off to the side. And here, this means I'm going to evaluate. Well, this is a special case, so it doesn't matter what it is, it's at 4. Now, I have to pick a second point in order to create my line. So I'm going to go ahead and make it easy on myself and pick -1. And here again, this is going to be a constant. It's going to be a horizontal line, and so we're still at 4. Now for the second one, we're looking at x, and then f of x equals 4 minus x squared. And then in this case, we are going from 0 to 2. So I'm going to use 0, and I'm going to use a 2. And here, if you look, 0 is included, so I'm going to put a little closed dot off to its side. But my 2 is not included, so it's going to get a small little open dot off to its side as my reminders of what's going on. And so here I've got 4 minus 0 squared is equal to 4. And then I've got to do 4 minus 2 squared. So 2 squared is 4. 4 minus 4 gives me 0. Now last but not least, I have to look at x and f of x being 2x minus 6. And we're going to come back to this middle one here in a minute. But to do this last one, we are looking at starting at 2, and we are going to include the 2 there. And then we are looking at doing values greater than that. So I'm going to look at 3 as well. Well, here I've got 2 times 2 minus 6. So 2 times 2 is 4. 4 minus 6 gives me -2. And then here I've got 2 times 3 minus 6. Well, 2 times 3 is 6. Minus 6 is 0. So let's start looking at some of these graphing points. So first and foremost, we're going to go ahead and graph our constant. So we have here 0, 4. So 0, 1, 2, 4. And it is an open circle. And then we have -1, 4. -1, 1, 2, 3, 4. And so here's our next point. And so we are coming in this direction. Now, the other thing that we need to note here is that in this new one, or the second one, okay, so we'll do this one in blue, we've got the same point here. We're at the point 0, 4. So notice I'm shading this in because now it is included into the second one. And then my second point is over 2 and 0. And so here we're going to have this downward motion as we attach this piece of your quadratic. And then the last thing that we have is we have the last one. And so here we're going to go 2, but down to -2, and this is included. Oh, and pay attention, this one should have been an open circle here. So this one is included here. And then at 3, we're at 0, so this goes right here. And then this is going to be a line that's going to go up in this direction. Okay. And so that is your piecewise function here. So what is it that you're responsible for? Well, right here, as you can see, is going to be the practice. This is what shows up. This is the part that is assigned to you. So you can see you've got 4 graphing functions on this side, and then you've got your piecewise functions on that second page. So this is what I expect to see for your participation piece. Again, if you have any questions, please make sure that you use the discussion board, as that will be what fuels our virtual class time.